Good afternoon, good evening. This is meteorologist DT with the video podcast for Monday afternoon, evening, I guess, 5 p.m. January 1st. Sorry this is a little late, having some computer problems, but things are working out much better now, so let's get right to it. A lot to talk about. We'll talk about the severe cold. It's going to continue, make it worse, with even some sub zero readings in Western Virginia, the Shenandoah Valley, Western Maryland, Central Maryland, much of interior Pennsylvania. Even in the mountains of western North Carolina, West Virginia, January 5, 6, and 7. Big issue is going to be January 4th. There's a range of possibilities here. Complete miss, a glancing blow with a little snow on the coast, heavy snow on the coast, and then maybe even a monster snowstorm for I-95. And then I was going to talk about the January 8th event, but don't have the time to do that, so I'll just skip it out completely. All right. Yesterday, and on the Twitter account, I made this comment here that what could get the huge ocean low to come closer to the coast. For days, none of the models have showed a 500 low developing over the Mid-Atlantic, or the Southeast U.S., which could grab the surface load and pull it closer to the coast. That's been the problem. So when the low forms over the Bahamas, it's too far to the east. The low's not forming over Georgia or northern Florida, it's over the Bahamas, and that's the problem. Now, keep that in mind. Now, here are morning low temperatures tomorrow morning. You can see how very cold it's going to be again. Really very impressive cold out there. Now, Wednesday, it's not quite as cold, but a lot of areas still in single digits in the teens, as you can see. And even 18 degrees in Norfolk, if you can believe that. So pretty cold temperatures even in Southeast Virginia. And low 20s even into northern South Carolina. A lot of single digits in West Virginia, the Shenandoah Valley, western and central Maryland. Very impressive in Pennsylvania. And then after the storm passes, here comes the Arctic blast and the strong winds behind it. So even if this thing is a complete miss, the winds on January 5th are going to be pretty darn impressive. Again, low teens, lots of single digits and sub-zeros. And I think the coldest will be January 6th. That's 7 degrees in Richmond, 9 degrees in Norfolk with a due north wind, if you can believe that, 3 degrees in Philly. 6 degrees in Charlottesville, sub-zero, the Shenandoah Valley, you can clearly see that, and the mountains of western North Carolina, a lot of West Virginia, western Maryland, most of Pennsylvania, the Ohio Valley. Again, if there's snow on the ground in the Mid-Atlantic region, these temperatures will be significantly colder than this, so keep that in mind. All right, and then Sunday, January 7th, also a very, very cold morning, no wind here, also quite impressive as you can see. All right, now this was the European model here from early on the 31st, and you can see it had this little band of snow along eastern North Carolina, southeast Virginia, Delmarva, and then a big area of snow, as you can see, in over eastern New England, which makes sense given the track of the system. Very viable scenario. The 12Z run yesterday, same sort of thing, but all the big snow is up in Maine in eastern. And the eastern, southeastern Canada. So what the European model doing yesterday had the low here, but there was a surface trough which was bringing snow to east of North Carolina, southeast Virginia, pretty much east of Richmond, Norfolk, and maybe the northern neck, and good snow into southern New Jersey and the Delmarva. But the big snow is up in here. I think there was some light moderate stuff in this area, but no big deal. All right, so that's what it was showing yesterday. Now, these are the early morning models here for January 1st. And the thing that we're talking about this issue back here. Let me bring this up again, my tweet. The 500 low grabbing it. So that's what we're looking at here. And again, these are the models here for early on the Monday morning. And none of these models are developing a 500 low. We have two distinct jet stream branches. Here's our northern branch. The northern shortwave is here. Here's the southern shortwave. Two pieces of energy. Northern shortwave, southern shortwave. On the Canadian. Northern shortwave, southern shortwave. Now, they're not exactly phasing. They're kind of like getting close to each other. And what the models are doing is they're seeing this low, this northern piece of energy, kicking this thing off the coast. But I'm not sure if it's going to do that. And that's kind of what the issue is. So then the 12Z model started coming out here. Now, the one on the left is the NAM, the 3-kilometer NAM. And you can clearly see the short wave, and again, let me highlight this so you can see it. Notice what it's doing here. Here it is, and look see the dip? There, that is a 500 low forming right in here. Now, the RGM doesn't have that. Two pieces of energy doesn't have that. And the GFS kind of shows something maybe trying to form there. There's a northern piece, there's the southern piece. They're not phasing, not according to the models. And when they do finally phase, it's too far to the east. Now, this is the Canadian model, and from this morning, 12Z run, okay, the afternoon run, I should say. So there's the low at 30 and 70 at 72 hours. You can see it right here. Let me highlight it so you can see what I'm talking about. There's the low, 30 degrees north latitude, 70 longitude. The red line shows an inverted trough, and there it is at 9:90 on the evening of Wednesday evening. And this is what might bring snow to the coastal areas, the inverted trough. And then here's the low parallel on the coast. You can see on the morning of January 4th, east of New Jersey, well to the south of Nova Scotia, and it's way out there. I mean, it's a big storm, but this thing is way out there. I mean, this is 70 longitude, and this thing is to the east of that on the Canadian. So it's way out there. So, and it takes it due north. You can see red line going right to here, due north into Nova Scotia, Halifax. They are in for a monster storm, just a historic blizzard of exceptional intensity and ferocity here. Now, this is the UK model, the British model, which a lot of people a couple of days ago were ass-kissing because they thought it'd bring in snowstorm. Now, look where it is, way to the east. It's a miss for the entire Mid-Atlantic, and even interior New England, New York State doesn't get anything substantial out of this. Yeah, maybe a little bit of snow, but nothing substantial. We're talking big snow. The UK Met is a miss. The British model here is a miss. Now, this is the European model from this Monday afternoon. And you can see the low here. I drew the red dots so you can see it. There's the certain one low. There it is at 84 hours, and this is at 96 hours. So this is generally a miss. It's too far to the east. And the problem remains that the low forms in the Bahamas. It does not form here. It forms here. That's not a great track for the East Coast. Now, here's a 12Z GFS European model. Excuse me, this is the GFS ensemble. And you can see a comparison here. Now, this first one in the upper left, this is the GFS from Sunday afternoon. See where the mean low is? Here. And look at all the red numbers. See the red numbers? Now, we drew a longitude line here. This is 70 degrees longitude running right. Actually, it's 69, but you can see the red line running right across the Vermont-New Hampshire border, straight southward, over Boston, and then straight southward. See here, all these red lines, the red numbers, are generally east of the red line. Now, this is Sunday. This is Monday morning, the one in the upper right. Monday morning here, okay, at 1 a.m. this came out. And you can see, again, look where all the red lines, they're a little closer together, they're closer to the red line, but most of them are here. And then finally, this is the one came out at 1 p.m., the bottom one here. 1 p.m. today on Monday afternoon. Now look where all the red lines are, red numbers, excuse me. Many of them are to the west. This is shifting to the west. But is it close enough to bring snow? Otherwise, it's still a near miss. Now, we have time here. We can shift. We have another 48 hours to go, so it's possible this could shift even further to the west. This is the GFS Ensemble QPF. So let's take a look at this carefully. Now, this dark green band, this is a quarter of an inch to half inch. So with these snow ratios, that's at least 2 to 4 inches of snow, maybe 3 to 6. And this is Norfolk right there, in case you don't know where that is. Now, here's Richmond, just get traces. D.C. gets nothing. Philadelphia gets nothing. New York City gets a little bit. Atlantic City gets a little bit. Salisbury also gets 2 to 4, 3 to 6 inches. Interior eastern North Carolina, Elizabeth City, maybe Fayetteville gets accumulating snow out of this. That's what the GFS Ensemble mean is showing for precipitation. Now, here's the Japanese model, okay? From early on, this is from Monday afternoon. Look where the low is, folks. Here, this is a kiss of death in terms of a big East Coast snowstorm most of the time. There is a way, there is an exception, but we'll get to that in a second. So there is the low forming, okay? So we see that, and now we go, here's 72 hours. Look where the low goes. Now, this is normally a pretty good track for a snowstorm. Most of the time, you put a 977 low east of Norfolk, Virginia, you got a huge snowstorm for the entire Northeast. The problem is the low does, the problem is the low is here at the start, like we said, and it does this. If it was over Georgia and it did this, yeah, baby, everybody be having a good time. It doesn't do that. That's the difference. I've been pointing this out for a while. Bahamas are not great for East Coast snowstorms. And then the storm goes bonkers way up there in southeastern Canada. You can see it. In case you can't see it, let me highlight it for you. Look at this monster up in here in the Japanese model. So all the models are showing the thing bombing out. We don't doubt that's not really the issue. Now here's the QPF, the precipitation map. And, we could enlarge this a little bit, and I will in a second. But you can see, there's accumulating snow, a half-inch liquid into between Richmond and Norfolk, a little more over Norfolk, eastern third of North Carolina, along the Jersey coast, Long Island, eastern New England. You can see eastern Mass. Rhode Island gets a decent snowstorm out of this. But if we look at this enlargement here, this is the Japanese model enlarged, and you can see the QPF. Now, here's Richmond. If we just put in the Richmond area right in here, there's Richmond. Okay, and so this is a 1 inch of liquid. So that's a foot. That's 12 inches of snow in Norfolk and Hampton Roads and Elizabeth City. If this is right, if this is right, if it's not a forecast, if got it. And now the dark blue is a half inch to 3/4 of an inch close to Richmond and towards Raleigh. That's Raleigh in here, folks. And there's Williamsburg and Newport. There's Salisbury right in here. That's a big snowstorm for these guys. This is bigger than a 10-to-1 ratio. This is 15-to-1 in this Arctic air. So this is a big deal if this is right. But this Japanese model, it's probably the wettest of any model I've seen so far. Now, that being said, here comes the new SHREF. Now, what is the SHREF? Short Range Ensemble Forecast. It consists of 15 different members of the short range models. 15. Now, this came out early this morning around 4 a.m., and this is the afternoon update. Notice the shift here. Again, the light green, a half inch to 3/4 of an inch. That would be 3 to 6 or 3 to 7 inches of snow. East of Richmond, okay, and then look over Norfolk. That's an inch of liquid. In eastern North, all snow. Salisbury, Maryland, half inch and inch liquid. And then it even has accumulating snow into D.C., past Richmond, almost past Raleigh. But the new one is even more impressive. It's got significant snow of 75 to 1 inch into Richmond. This is 8 to 12 inches minimum and even more. This is 1 to 2 feet in Salisbury, Norfolk. But this is the SHREF. It's always too wet. Let me type this out here so you can see this. Always too wet. Okay? We are not forecasting 1 to 2 feet of snow in eastern Virginia, eastern North Carolina, the Delmarva, or eastern New Jersey. Not. But the trend is kind of important. The trend. Now, this is the European, and this came in from early Monday morning. You can see, and again, it does not have a 500 low here forming over the southeastern states. We have two separate pieces of energy. The southern jet stream is here, and the northern one is here. And what the European is doing, the European is using this one to drive the low off the coast. But is that correct? And here's the European, and you can see the trough. Look what the low is. In case you can't see it, the low is right here. Look how far to the east this baby is. Wow. But there's an inverted trough on the coast, which puts the precipitation close to Richmond in heavy, moderate precip into Norfolk and Williamsburg and Tappahannock and Gloucester Bay and Salisbury in southern New Jersey and northeastern North Carolina. This is several inches of snow here. And you can see it continuing, and then actually, New York City does not get a big snow out of this. Neither does Western Connecticut. Eastern New England does, and then of course up into southeastern Canada. If you look at the actual QPF, you can see where it is. It's a decent snowstorm for interior eastern Virginia. Now this is the new one, of course. This is the Sunday afternoon, and it actually produces a couple inches of snow in Richmond now. So the snow shield has expanded a little further to the west here, a little bit, and it's got heavier precip. Half inch of liquid into Norfolk, and you can see that's 6 or 8 inches of snow at least, given these cold temperatures. Also northeastern North Carolina, a couple inches in towards Raleigh. So again, this is an interesting trend. If we look at the snow map from the European, 6 inches in Norfolk, 1 to 2 inches in Richmond, 6-7 inches in Salisbury, Wallops Island, a couple inches in southern New Jersey, and more. And again, northeast North Carolina, Fayetteville, Elizabeth City, definitely a Hosky, at least several inches of snow on the European model here. And we can see that continuing up. And if we look at this in high resolution from the folks over at weather.us, you can see the model actually produces 9 inches of snow, 6 to 8 with a few 9-inch amounts over the lower Virginia eastern shore, Melfa, Accomack, as well as Norfolk, Chesapeake, and Virginia Beach, and up to 2 inches in Richmond, and then 2 to 6 inches between Richmond and Newport News and Williamsburg. Actually, that would be a 2 to 4 inches, excuse me, from Richmond over towards Williamsburg and down towards Emporia and up towards Patuxent River. And you get pretty big snow here, decent snow over lower Maryland and the Delmarva on the European. And if we look at the total from the European, again, notice how the European has here not much. It's got good snow in eastern Virginia, eastern North Carolina, the Delmarva, and then some stuff up in here. But this whole area here is kind of like the screw zone on the afternoon European. If it's right, I don't know yet. Now look at the European ensembles. Here it comes. There's the low, all compact together, strong ensembles. A lot of a lot of these little red L's, you see these red L's, are to the west, which would be a closer, bigger snowfall for eastern Virginia, eastern North Carolina, and the Delmarva. And then from here, this system just takes off to the northeast, going up towards Cape Cod, and then look what it does. From here at Cape Cod, it goes in a northeast direction, as you can see. Boom. This is going to be a monster storm for eastern Maine and Newfoundland, New Brunswick, Nova Scotia. Oh my God, those guys are going to get just crushed. Okay, now there is a way of getting around this, maybe. The January 24, 25, 26 surprise snowstorm in 2000. A lot of people talk about this, a lot of weather hobbyists, a lot of weather weenies. It was a surprise snowstorm that was supposed to go out to sea. It did not. It's gotten a lot of attention. Everybody who has any desperate attempt to get a snowstorm on the East Coast always mention this event. And it gets overplayed. In this case, there is an analogy to it. In that particular storm, we had two pieces of energy. This is the upper air map on the morning of January 24th, 2000. Now, this is the southern piece of energy right here in red, okay? And here's the blue one. Now, we have two distinct jet stream branches. We have the polar jet here. This is the polar jet in blue, okay? And here's our subtropical jet in red. So the northern piece is not going to phase with the southern piece. It's going to kick it out to sea. That's what all the models are forecasting. Again, there's the 500 low forming over Georgia, which is what the NAM is showing. And then the northern piece of energy coming down, it's going to kick it out to sea. And this storm is going to go out to sea. A miss for everybody on the East Coast. That's what was supposed to happen. And then what instead would happen was, here it is on the morning of the 25th. This upper low, this piece of energy, did not swing this way. It dropped this way. And what that did was that forced the low to come up the coast. For every action, there's an equal and opposite reaction. And it drove it up the coast. And we can see that happening very nicely. Here is on the, this is for, you can see the morning of the 25th. And we can see very clearly the northern piece of energy coming down this way. Here's the upper low forcing it up the coast. And here comes the snowstorm. Wham! Hammering North Carolina, Virginia. Okay, Charlotte got 21 inches of snow. Richmond, 18 inches. D.C., a foot of snow. Salisbury, 18 inches of snow. It was a big snowstorm for the Mid-Atlantic. New York City got like 6 to 8 to 10 inches of snow out of it. Not that much. And then we can see the trend continuing. Again, this piece of energy, look what it's doing. The northern piece is coming south, and that's forcing the coastal storm up the coast. For every action, there's an equal and opposite reaction. There it goes, and you had your snowstorm. And then finally, I think the last image is this one, and this is on the afternoon. This is the evening of the 25th of January, and the snowstorm is raging up and down the mid-Atlantic coast. So there is a way for this to happen, and this is how the snowfall map looks. This is for Richmond and Virginia. You can see how big it was for central Virginia. It was a huge snowstorm, as you can see. This is for D.C. You can see the big snow in D.C., Fredericksburg, up towards Baltimore. And then up and down the East Coast, it was a massive snowstorm from Charlotte, you can see in here, all the way to Baltimore. And then not that much in New England, which went over to rain. Boston went over to rain, and moderate snow up in here. But it was a very big snowstorm for Virginia, North Carolina, in the central areas. So that's the way it could happen. If the upper low gets coming in from the north, drops down and grabs the southern stream. So it's not likely. Most of the time, this does not happen. But we have to watch it carefully and see how it plays out. This is meteorologist DT from Weather Risk. I'll catch you on the Facebook page and on the Twitter account.